So this is Pencast for homework 1, number 12, and the question says, the displacement of a wave traveling in the positive x direction is dxt equal 3.5 centimeters sine of 2.7x minus 124t, where x is in meters and t is in seconds. And it asks us to find the frequency, wavelength, and the speed of this wave. So first thing we need to do is find the frequency, and we can do that by thinking about what the equation is for a wave. So we know from lecture that the equation for a wave is given by this equation here, dxt equals a, where a is the amplitude, sine of kx minus omega t, where k is the circular wave number, and it is given in rad over distance, so in this case rad over meters since we are dealing in meters, and then omega is the angular frequency, and that's given in rads per time or rads per second. So you can see here that this number is going to cancel with the number here, where you have meters over meters, so it's going to be like, and this is going to cancel with time, and then these are going to cancel out. So to find the frequency, we have to use some other equations that we've learned that are related to k and omega, and specifically to find the frequency we need to use omega. So one of the equations we have available to us is omega is equal to 2 pi times the frequency. And we know that omega is 124 based off this equation. Just kind of think that we switched out this omega, or the w, with 124. So we have w is equal to 124. It has to be rads per second. And then we have 2 pi rads, and then we need to find the frequency. So taking this equation and solving it for f, we can get frequency is equal to omega divided by 2 pi. And 2 pi is in radians. So then if we plug in the number we have for omega, 124, we have 124 rads per second over 2 pi rads, or radians. And we plug that into the calculator, 124 divided by 2 pi, and the radians cancel, the seconds goes into the denominator, so then we get 19.7, we can round that to 20, but 19.7 1 over seconds, which is equal to 19.7 hertz, which is about 20 hertz if you round it up. So that's our answer for part A. The frequency for this wave is 20 hertz. So part B asks us to find the wavelength, or lambda. Yes. Looks like that. So to find the wavelength, we kind of do something similar we did for part A, but instead of using this equation, we use a different equation that relates to k. So we have given to us, it's on the equation sheet, k is equal to 2 pi over lambda. And if we solve this equation for lambda, or wavelength, then we should be able to put in the number for k and get the wavelength. So if we multiply this by on both sides, we get lambda k is equal to 2 pi. And then if we divide out k, we get lambda is equal to 2 pi over k. And then we just plug in our number for k, so 2 pi over 2.7. And this is in units of radians over meters, and the 2 pi is radians. So you can see that the radians will cancel, and the meters, since it's dividing, the meters is going to go to the numerator. So then we're going to get 2 pi divided by 2.7, which is equal to 2.3 meters. And that's going to be our answer for part B. Wavelength is 2.3 meters. And part C asks us, what is the speed of this wave? And this is going to be pretty easy to solve since we know A, the frequency, and B, the wavelength. So we know one of the basic equations for waves is velocity, which is the speed of the wave, is equal to the wavelength times the frequency. So if we plug in our two values that we found with 2.3 meters for the wavelength, which we found in part B, and then for the frequency is 20 hertz, or 20 over seconds, which is the same thing as 20 hertz, we can find V. So we just multiply these two numbers, so 2.3 times 20 is 46. And you see that these units go over each other, so we get 46 meters per second. And that's our velocity. And that's how you solve the problem.